All right, so Rochelle is about to join us. This is going to be the key that I'm working on. My voice is totally gone.
She said she's not feeling well.
Okay, hold on. I'm not sick. My son was sick. I didn't catch it. I might have got a sore throat, but that is it.
Anyway, when
So,
is Odin's Day?
Odin's Day. All right.
I think they're all named for like gods or something.
I would believe it. G of 1. So G is defined by this accumulation integral of f of t, and we have some random. F of t is actually defined by natural log of x times sine of x, so it's kind of a hard function. I need to find G of 1. Notice that it's problem number 4, which means you have no calculator. So G of 1, I'm going to have to actually plug in 1 here, so it's going to be the boundary between 1 and 1 of f of x, which is going to be what?
0?
0, yeah. So this boundary between 1 and 1 of f of t, I guess, dt, is 0. Pretty straightforward. Let's do g prime now. G prime of 1. Now I'm going to take the derivative of an accumulation integral. Can one of you two remind me how do I do that?
Bring down that x from the top.
Exactly. That x now gets plugged in, and I get rid of the integral. Because the lower boundary is a constant amount, I don't have to worry about it. Ignore it. It doesn't matter if it was 0, 1, 5. So it's going to be f of x. And yeah, now we need to find that. What is f of x? Is that height, slope, concavity? On the graph of f, what is f of x? Height, yeah. So we'll write down height. H-E-I-G-H-T. Height. So what is the height at 1?
0?
Yeah. So at 1, the height is 0. So they're both 0. Kind of cool. All right, let's talk about part B. On what intervals, if any, is G increasing? Okay, definition of G increasing. What does that mean? There it is, G prime greater than 0. Thank you, Sophia.
Yeah.
All right, and what is G prime again? G prime is?
Height of f of x.
Yeah, so where's the height greater than 0? So let's look for those intervals. That's pretty straightforward, right? The height is greater than 0 between 1 and that value, which we're going to have to find without a calculator.
Oh.
Because it's not exactly 3, but we know that the height of 0 is this 1, and right about there, which probably is pi, 3.14, I would guess, since we have a sign in here. What is the sign of pi?
0.
It is 0, yeah, because if I'm doing sign, that's talking about the y coordinate. So this value is actually pi. So G is increasing. G is increasing on the interval 1 to pi. 1 to pi. And then we'll add the note here in case anyone is confused looking at this, that sine of pi is equal to 0. Cool. That's all of part B. Now we're on to, okay, so hold on. We messed up. We didn't justify. In part B, it says justify your answer. So we have to say, we did have this definition, so if you already wrote it down, you're good. But our full answer is because G prime is greater than 0. Now we have the full answer. Now we can go to part C. All right. So on that interval that it gave us, find the value of x at which G has an absolute minimum. Absolute means we're making a table. All right. So we're doing t values. We're going to do...
Well, I think you don't really have to make a table because it could only be 1.
Yeah, but we can pull it out after we make the table because tables are just.
Yeah, but you can just say, you can just explain why you don't have to consider them.
Yeah, you're right. You don't actually have to make a table. So let's talk about, so there are only 3 things that can possibly be an absolute minimum. Start, end, and CVs, right? What is the definition of CV? GCV. What is that definition?
G prime sign change. Oh yeah, it's just a C.
G prime.
Sign change. No.
G prime sign change is relative extrema.
Well, actually, there's that point at 1. That's
Okay, Ben, you're going too fast. What is the definition of GCV?
F equals 0.
Okay, you're right in terms of F. Are you okay, Rochelle? Okay. But in terms of G, what is it? You're, again, skipping too many steps, Ben. In terms of G,
Oh,
what is the CV of G?
G prime equals 0.
There it is. And then I'm going to do everything that Ben said from there. G prime equals 0 is the same thing as saying this implies that F is equal to 0. And then Ben did the next step already, which is what is the height? Where do I have a height of 0? And we already answered that at 1 and pi. So our table, we're looking for minimum.
I think we do need to make a table.
All right, we'll make a table, but let's go ahead and analyze each of these points. Can this x value of 0 be a minimum? Or the absolute minimum? No. Why?
Because it's negative space right directly after.
Yeah, it's followed by this negative area. Can this value of 1 be an absolute minimum?
It could be, but I'm just eyeballing it. It's not.
It could be. So we do have to include 1 on the table. It could be because it's preceded by the thing before it is negative area. Could this value of pi, which is a CV, a critical value, could that possibly be an absolute minimum? Because yeah, so it goes from a positive to a negative, so it's at least a relative extrema, and a relative extrema can't be an absolute minimum. Or relative max is what you defined. A relative max cannot be an absolute minimum. And also another reason that you can explain is it's preceded by a positive area, which is the reason that it is a relative extreme or relative max. Right. So far, 0 can't be, 1 could be, 3 can't be. Could 6 be a relative minimum?
It's not 6. It's 2 pi, right?
Or yeah, sorry, 2 pi. Could 2 pi be a relative minimum or an absolute minimum?
Yes.
Yeah, and in fact, it probably is because there's this giant negative area right beforehand. So let's go ahead and make our table where we include values of 1 and 2 pi, and we'll write a note saying we're not including 0 and pi because it's because it's followed by a negative area. I'll write that up here before I forget.
And you have to write that down.
You don't have to get the points in most cases, but it's always nice to. It should only take you like a few seconds to write that down. It's not too bad. Not including x is equal to 0 or pi, because followed by negative area. That means our table, and I'm going to have to squish this in because I need part D. My table is going to have values of t start, which should be 0 plus change. So values of t that we are going to look at, 1 and 2 pi. It doesn't say any start, right? Nope. Okay. So start is 0, 0 plus the integral from, and our integral is defined. Oh, shoot.
There's a 1 there.
There's a 1 there. That changes everything. If it went from 0 to 2 pi, then obviously we're okay. Our analysis is sound. But because there's a 1 there, is this integral right here positive or negative?
Positive.
It's positive now. Why?
Because you would subtract the negative integral.
Because you,
Maybe a negative integral when it goes from 1 to 0.
And then
because yeah, you need to switch the bounds, right? My bound would go from normally 1 to 0, but that's incorrect. So this integral right here should be the integral between 1, because it always starts at 1, to 0. But that's incorrect. I need to switch the bounds, which means I need to do negative integral this turns into a negative integral from 0 to 1, which means if I had a negative area, it is now a positive area. Are we all okay with that? Okay. Let me get rid of that. Which means 1 also can't be a relative, one shouldn't even be on the table.
If you're going back towards 0, then it's increasing. So going forwards, it's decreasing as you get less of that now positive area.
No.
Only from the point of 1. Everything in our analysis from here to the right is still straightforward. You still have positive area, negative area.
As you go from g of 0 is going to be greater than g of 1, so g of 1 could be a minimum.
Oh, I see.
Because as you go towards 0 from 1, you're adding.
The problem with that analysis is really all you're doing is making this into a positive bump. You're still preceding this by a positive area.
Because there's no side change.
In between positive area and positive area, you still can't have you can have a relative minimum, but you definitely can't have an absolute minimum. This is equivalent to looking at the graph that goes like this. Like, yes, you have some CV right here, but it's still just going up. It's not actually going to a minimum where you start going up to down. It's going up to up, positive to positive. This is looking at, if this was like taking the integral of this guy, I'm looking at this graph.
Oh, I see.
So really, that is our entire analysis, because we were going to include 1 on the table, but 1 can't be on the table. If you want to leave it on the table, you can, or we could just say, I think it's faster to now say, oh, that G is going to be caught, that's okay. It's faster to say also not including, or x equals 1 can't be an absolute minimum because also followed by, or because preceded by positive area. And we're basically done, which is really nice, because if we did it the long way, we'd actually have to start finding the actual areas of natural log and sine. We don't have to do any math aside from an analysis. And you can do a little therefore symbol. These 3 dots mean therefore x equals 2 pi is the absolute min. And it doesn't ask for what that is, it just asks for where. Find the x value where it has an absolute min. And we did. So far so good? All right. From there we're going on to part D. Is there a value of x at which the graph of g is tangent to the x-axis? What does that mean? What does this tangent to the x-axis mean?
F prime or g prime equals 0.
Yeah, it just means, so a tangent to the x-axis means this slope, right? It's really asking for a horizontal tangent, right? Oh, but it's the graph of g. So it is going to change a little bit, right? It's not the graph of f, it's the graph of g. So what is that trying to say? I think it's still saying the same thing, right? Where
G prime equals 0.
yeah, where g prime is equal to 0. This is still saying g prime is equal to 0. And we did that. So D. G prime is the same thing as f. And f is equal to 0. Where? At those 2 points, at 1 and pi.
Also 2 pi. It's a closed dot.
Oh yeah, and it is including the 2 pi. So at 1 pi and 2 pi. Okay, I believe it does say justify your answer too, or explain why or why not. Okay, so what is our rationale? We're going to say because we basically already said it, we just need to restate it. Because, yeah, that's enough. Cool. That's the free response question. Any questions? Michelle, Ben? Oh, okay. We're on to multiple choice. Ooh. Number 14. What do you immediately see in number 14? What method should you use to solve?
Hotbox?
Yes, it is. It is a hot box. So anything that has an H in it, that's going to be your box. Step 1, draw your box. Step 2, what is the constant? What is the thing being added to H? C is equal to 2. And then next step is to make that whole thing an X. So it's e to the power of X. So that means our function is e to the power of X. And since this is the definition of the derivative, it's now we need to take the derivative and plug in 2. So f prime of x is equal to what? Still e to the x. Derivative of e house is e house. Therefore, f prime, when I plug in 2, is e squared. Very nice, very nice. All right, so f prime is given by the absolute value of x minus 2. Which of the following could be the graph of the antiderivative of that? So it looks like A is actually graphing f prime. So a good way to visualize f of x is to look at the area underneath A. What is that area doing? Any ideas? Okay, I'll give you this hint. Is this area between this curve and the x-axis always positive or always negative? Okay, if it's always positive, what do we know also about the slope then? It's always positive. So we're looking for a graph that is always positive. Do you see it? There it is.
Also, D is always positive, but it's not continuous.
Oh, it's not continuous. Okay, so it could possibly be D also. Why is it E and not D?
Because D doesn't have the same ending height.
Ooh, I don't know if it's E anymore. So if I'm looking at slope on f prime,
You have to look at height.
I'm looking at, is it height on y?
Shouldn't it be height if you're going backwards?
Okay, if I'm going backwards, I should look at height, otherwise I'll get to concavity, you're right. So let's look at height. Height on f prime of x is equal to what of f of x? Height on f prime of x is equal to what on f of x?
Slope.
Slope. So notice that the height here is pretty consistent. It's still 0, and then it slowly goes back up, which means height is continuous. The height is continuous, but the slope is not. The slope obviously goes -1, and then just randomly changes to +1, +1. But the height is continuous, which means the slope should also be continuous. You can't have this discontinuity. So I'm pretty sure the answer is E. Another thing to look at is that you should eventually have a slope of 0. This does have a slope of 0 here and a slope of 0 here. Yeah, I'm having trouble explaining why it's E and not D. Does anyone else have a better explanation?
Well, that would, I guess that would have to be a piecewise function. Something like that. For it to be like that.
The problem is absolute value is a piecewise function. All right, I guess we can come back to that if we have more time at the end of class. Let's do number 17 and 21, then we can be done with this. Number 17. We have these two graphs, and I need to find the area in between them. And I don't believe we have a calculator, so you're going to have to do this by hand. Can you tell which one is on the top and which one is on the bottom? And I guess for multiple choice, it doesn't really matter, right? If we get a negative answer, just change it to a positive answer, and then you'll get the answer, right? So let's go ahead and do this. The integral, oh, but we need the bounds.
Yeah.
How are we going to find the bounds?
Usually a calculator comes to mind.
Yeah, how do you do it without a calculator?
Would you equal them to 0?
You set them equal to each other. If you set them equal to each other, what you're saying mathematically is when does this function equal, when does the height of this function equal the height of the other function? And you'll find the x-coordinate where those two functions intersect. So when I set them equal to each other, then I'm left with, I'm going to get everything on the same side. I'm going to move everything to the right-hand side here to make it a positive 2x squared. So I'm going to say 2x squared minus 6x, that's going to be set equal to 0. Obviously, I can divide both sides by 2, and I get x squared minus 3x is equal to 0. And if I now factor this, I get x times the quantity of x minus 3 is equal to 0. Using the zero product property, this x could be 0, or this x minus 3 could be 0, which means my two x's are 0 and 3.
Wait.
So that means when I'm doing my integral, I'm doing my integral with bounds from 0 to 3 of these things subtracting each other. So I'll do x minus 2x squared minus negative 5x. All of this thing dx. But I don't need to be formal because it's multiple choice. Let's just go through this. So this is going to be x squared over 2. Actually, I can combine like terms before I do this, otherwise I'm going to make it too hard on myself. I'm really adding 5x, so I should have a 6x. This term, sorry, I'll do this in yellow. This term and this term add to 6x. So antiderivative of those two terms is 6x squared divided by 2, which is really 3x squared. And then finally minus 2/3 x to the power of 3. And that's going to be evaluated between 0 and 3.
Wait, what happened?
All right, so just as a review, this negative 5x is really plus 5x. 5x plus x is 6x. 6x. Then I raise power, divide down. And for this one, 2x squared, 2x, raise the power to the power of 3, divide down. All right, when I plug in 0, nothing happens, which is really nice. That means I just need to plug in 3 and see what happens. 3 squared, 9. 9 times 3 is 27, so I have 27 minus, and then when I plug in 3 here, I get 27 divided by 3, which is 9. 9 times 2 is 18, so minus 18. And I believe 27 minus 18 is 9. Any questions? I can re-explain it if someone wants it. All right, then we're going to go on to number 21. That will be the end of the video. Here's a graph of,
What happened to the 5x?
so the minus minus 5x was being absorbed by this other x. So this x and this minus minus 5x made a 6x. Yeah, good question. All right. So we have a graph of f prime from 0 to 10, and we have their areas. Cool. So it tells us this start condition. The start is 2. I'm looking for the maximum value of f. And this is kind of weird to me because I don't think we need the start condition to find the maximum. Oh, we do, okay. We can tell where the maximum happens, but in order to find the actual maximum value, we have to always add 2 to it. So it's going to be 2 plus whatever numbers. So let's do our analysis. Where could the maximum happen? Could the maximum happen right here? No, because it's followed by positive area. Could the maximum happen right here? Yeah, because it's preceded by positive area, and it goes from a positive to a negative, I guess. Could this value be an absolute max?
No.
No. What about this one?
No.
I mean, it might, but probably not because it's so tiny.
Just 4 versus 6.
Yeah, I mean, if this 4 was bigger than 6, then that would be the answer. But the answer is going to be this one because 6 is bigger than 4 and 6 is a negative area. So the answer is going to be 2, which is the starting value, plus that 20 for the answer of 22. All right. Any questions at all on anything we did today? All right. We have 19 minutes left of class.